Okay. The area of a sector shown is this much. Calculate the value of R. Alright, what's the formula? What's the formula, guys? Theta over 360 multiplied by? Why is it pi r squared? The area, isn't it? And that equals 12.56. Now, what's 40 divided by 360? Doesn't even matter. 3.14 here, yeah? Radius squared here. Alright, here's a little cheat for you. On the left, throw it all into. What we're going to do is we're going to have 40 over 360, which we all know is a ninth. And you're going to multiply that by 3.14, and you're going to stop. 157 over 450. Everybody cool with that? And what does it equal? 12.56. If 450 is division on the left, what happens when you move it to the right? Huh? Multiplication. If 157 is multiplication on the left, what happens on the right? Happy days. So, 12.56 multiplied by 450 divided by 157. Oh, actually went in equally. Shock horror. Now what's the R value? 6. Are we cool with that? Alright, I've done 35. What's the next one we're doing? 30 what? Am I doing 36 now? Okay. Yes.
Could you just say, since it's 1/9, could you just multiply?
Multiply it by 4 and then let's do the full circle.
Multiply 12.56 by 9. And
then do the full circle. Yeah. That's essentially what I did, believe it or not. See this here? That's 1/9, isn't it? And then you bring the 9 up to the top. Division on the left becomes multiplication on there. Right, so that would work, yeah. Alright, we're on to 36 now. Okie dokie. The area of the full circle, that's easy money. What do we get? Pi r squared, which is 2 over 7 times. Anybody?
14 squared.
Why is it 14?
Half of the diameter is the radius.
Yeah, half the diameter is the radius. And what did you get when you threw that in?
616 centimeters squared.
Yeah. Horizontal form. The perimeter of the circle, that's 2 pi r. What's 2 pi r? 2 over 7 times. And what you get? 88 centimeters. Okay. Area of ABC. Well, is there a right angle? A half base times height. What's a half? 14 times 14. 98. Then we get 98 centimeters squared. The area of the shaded region. Alright, we have a plan. Here's the plan. Alright, forget about the shaded region. Okay, by the way, that's 98. Every cool with that? Half 14 times 14 is 98. Alright. Now here's what I want you guys to look at. If you have a pizza slice, what fraction of the circle is it? 1/4. Would you agree with that? Or 90 over, which is, we all know, is a quarter. How big is the full circle? 600 and? So how big would a quarter of the circle be? 150. 4. Everybody cool with that? Divided by 4 and you get 154. Now, in that 154, what's it broken up into? It's broken up into 98 for this part, and what about the other parts? So 154 take away 98? Yeah, and that part must be So that would make it 56 centimeters squared. Any questions? Alright, I'm pausing. Guys, next one's a tricky one. I'm going to get rid of a couple of the numbers on the board. Get rid of that, get rid of that. Keep the 88. Get rid of the 56, get rid of the 98. And get rid of all this. Alright. What does it want from the next thing? It wants me to find, see this guy here? He's going to run 14. He's going to run another 14. Then what's he going to do? Run the outer curved section to the end. Now, we don't know what the red curved section is, do we? But we know what the blue part and the green part are. So it's going to be 14 plus 14. Now the next part's the hard part. What do we know about the full circle? If it was to run a full lap of the circle, how long would it be? It'd be 88, wouldn't it? How much of the lap would the red part be? 1/4. So 88 divided by 4? 22. Add them together. 50 centimeters. Everybody cool with that? Who got that one out? Ah, good. Alright, 35 and 36 successfully done. Let's move on. Alright, 37 and 39. Okay. Now, Veronica? Alrighty. So, I'm done. Okay, dokes. Given that the area of the rectangular strip is 80 centimeters cubed, find the value of x. Alright lads, that's not so bad. Look at this. Everybody see the rectangle now? What's the area of the rectangle? Length multiplied by width, which will be? 2x multiplied by 10 is? And 20x must equal? 80. What does that mean about x? How many people got that part? Alright, the majority. Now, 8 for this side, yeah? Because it's 2x. And what's the diameter? 4. What's the radius of the small circle then? 2. Use the value of x to find the area of the circular hole. So what's the area of the circular hole? Pi or squared, which would be pi times 2 squared, which is 4 pi. Do you leave it as 4 pi?
Centimeter.
And centimeter squared. Thanks, Ryan. So you're the top dog. Oof. Right. Now, centimeter squared. Cool with that? Now, what can I say about the two semicircles? What do they combine to make? Two semicircles is the same as a full circle, isn't it? So, I can find I get the area of the rectangle, and what do I take away? So, it's the area of the rectangle, take away the area of the large circle, take away the area of the... Does everybody get that picture? Area of rectangle, take away the large circle, take away the small circle. Everybody gets that the large circle is these two parts combined. Okay? So how are we going to do this? What's the radius of the large circle? 4, isn't it? Sec. My computer is having a great time. Oh, it's having a great one. Now, what we're going to do here is a radius of 4. So, would everybody agree that's 80? Yeah? Take away pi times, what's the radius again? So pi times 4 squared. And what's the area of the small one again? We got it already? 4 pi, don't we? It's going to be 80, take away 16 pi, take away 4 pi, what's minus 16 minus 4? Is that what we're asked to do? What will Ryan tell me? Centimeters squared. Who got that one? We're down to 2, 3 people, 4 people. Obviously 20 pi is not 2 pi. So 80 minus 20 pi. Thanks, sir. Move on. Alright. Sorry, not move on. 30. What's it? 39, isn't it? Alright, 39. Let's do this. Which has the longest perimeter? A circle of diameter 14 centimeters or a square of side 4 centimeters. Pretty handy. 4, 4, 4, and 4 gives me. Oh, sorry. Gives me what? 56. Alright. Next one. Technically, it should fit in. Should fit inside, shouldn't it? So, just for argument's sake. There you go, yeah? Bring it back out again. What's the diameter? What's the radius then? 7. What's the area? Pi r. What's pi times 7 squared in decimals, please? Oh, whoa, 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 whoa. Not looking for area. I'm looking for perimeter, excuse me. 2 pi times 7. And what is it in centimeters? Which is in decimal?
33.98.
Yeah, which one's bigger? Square is bigger, isn't it? Alright. So I've done 35, 36. Did I do 37? I've done 39. Awesome. Alright, keep going. I'm now doing none of these. So it's 42. Alright, 42, fun times. Alright. Now, a running track is in the shape of a rectangle with 2 semicircular ends. Calculate the length of the track. Alright, no bother. But everybody agree this end here and this end here, when you combine them together, what do they form? They combine a circle. Poorly drawn circle. Okay? What is the length of the green line? C equals 2 pi. Or, what's the radius of this circle? Half of 84? 42. Circumference equals 2 multiplied by 22 over 7 per pi multiplied by radius, which is 42. What did you just get? What? 264? 264 meters. What does that mean for each end? Each end is 132 meters. Is that okay? Am I right? Alright. What's the length of the lap then? You run around, you do 132, you do 68, you do another 132, then you do another 68. So it's 68 plus 68 plus 132 plus 132. Anybody got the answer for me? 400 meters. Just like the Olympics. You run one lap, you generally run 400 meters. How many people got that one now? Righty. Now, any questions about it? Owen?
There's a part two.
Now, get rid of all this and bring this upwards. And there is part 2. Just select that his own. Magic. Now, 2 runners complete a 400-meter race around the run track as shown. What? Well, let me read it first. Right. 2 runners completing a 400-meter race around the run track as shown. Yeah, you're right. It's the same size as the original track, okay? The runners on the inside track start at A. They run anti-clockwise, which means they run... Oh, they even put arrows here for you. Look at this. And you go... Right? And you start here. How far from P should the outside track runner start the race in order that the outside track runner covers the same distance as the inside track? So, we've discovered that the inside lane, this blue runner, how far does he run? If he stays on that line? 400 meters. However, this guy here, he's not going to run 400 meters. He's going to end up running longer. Does that make sense? So usually in the Olympics, they'll have the red guy start up here somewhere. Do you ever see that in the Olympics, the way they stagger it? So that's what's going to happen. So we have to figure out what we need to do. Now, first thing is, we have a big radius this time. So, the radius is no longer, look at this, wait. There you go. Do I have a full circle again? I do, why? I have part of it on the top and the other part's on the bottom. 2 semicircles, yeah? What's the radius of these, what's the diameter of this semicircle to start with?
98.
It's not 84, was it not 84?
7. Yeah.
You got to add on 2 sevens and what you get? 98 meters. What's the radius?
29.
Okay. What's the circumference? 2 pi r, which is going to be 22 over 7 times 49. What you get? 208?
300.
308, sorry, my fault. 308 meters. Cool with that? Whoa. Something's wrong. Oh no, it's not wrong. What's 308 divided by 2? Was it? 154. Somebody needs to be banned from answering questions. Now, 154 on the top, 154 on the bottom. The straight is still 68, isn't it? Once you add all these together, what you get? 444. Alright. This guy runs 44 meters too far. So what do I need to do with his position at the start of the race?
Starts 44 meters ahead of you.
Start him 44 meters around the corner. So the distance from this green distance will be the extra 44 meters. Does that make sense?
Yep.
Then they both only run 400 meters. Alright.